These are the section 6.2 notes. You need to have your textbooks open to page 342. You are going to need a ruler and maybe a couple different colored pens, just like we did in section 1. We will do a few graphs today. We're going to start talking about substitution, and basically we should talk about what this chapter is all about. We're going to talk about systems of equations for most of the chapter and how we can solve them, which means find the x and y value or the ordered pair that makes them true. Now, when we talked about them in section 6.1, it was a visual thing where we were looking at a graph and we could see this is where they intersect, that must be their solution. We're not going to have that when we start getting into things like substitution and elimination. So I'm just going to tell you, when you're doing these things, you're looking for the exact x and the exact y values that if you plug them into both equations in that system, it makes them both true. And that's what the solution is for a system of equations. When we talk about substitution, we are going to start plugging things in for variables that we know and then working them out to solve for the missing variable. And it's really quite an easy process. We're going to try it out today. We are going to do some graphing because we did graphing in section 1. So we're going to do the graphing alongside our examples today to double check our answers, make sure we did it right. I don't think that there's any of that on your homework, but if there is, that's great, because then you can double check, and if you get something different when you graph, then when you use substitution, you know you made a mistake somewhere. So the definition of substitution is the same as in normal math, where plugging a known in for an unknown or a variable to solve or simplify. We're going to leave it as to solve. So for substitution, the first thing you have to do is, remember, you're going to have two equations. You have an equation here and an equation here. Pick one of them, and if it's necessary, solve one of them for one of the variables. I want you to take a look on page 342. Look at the very first example. Do you see how the first equation already has y alone? They already solved that for you. That means you don't need to do step number 1 for this. But if you take a look at page, look at page 343 at the first, or example 2. Neither of them have a variable that's been solved for, so that's when you would use step 1 and solve for one of the variables. After you find that variable, you're going to have an expression. So just like on page 342, we had y equals 2x plus 1. 2x plus 1 is the expression, and you plug that into the other equation for that variable. We're going to do an example, and this will make a lot more sense, but we're just going to walk through these first. Solve that equation for the new variable, and then you're going to get a numerical value. You're going to get a number for that variable. Plug it into one of the equations and solve for the other one. And then you're going to have an x and a y, or whatever variables you have, and the last step is to write it as an ordered pair. We wrote it as an ordered pair in the first one, and we're going to do that for this one as well. So keep that in mind. We're not going to have graphs on the homework, but you should still write it as an ordered pair. So turn to the next page and we'll do an example. I even think it's the first example that you see on page 342, where it says, use substitution in order to solve the system of equations, and then use a graph to double check your answers. So let's just start by solution. I already know y equals 2x plus 1. So I'm going to plug 2x plus 1 in for y in that second equation. Okay, so over here in that 3x plus y, I know from the first one that y equals 2x plus 1 equals -9. So the only thing I did was, instead of putting a y here from that second equation, I put 2x plus 1 because I know from my first equation that that's what y equals. And so I can start simplifying. I know that that's 3x plus 2x plus 1 equals -9. I can combine like terms to get 5x plus 1 equals -9. To solve for x, I subtract 1 from both sides. I get 5x equals negative 10, divide by 5, x equals negative 2. Now I have a number for x. So then I just have to plug that 2 or negative 2 in to either of these to solve for y. I'm going to give you a hint. This one's already solved for y, so when I plug that in, I'm not going to have to do any solving. It's going to be easier. So we're going to pick the first one. I will tell you, though, it will not matter. You can choose the second one, and you'll get the exact same answer. So we're going to say y equals 2 times negative 2 plus 1. Y equals negative 4 plus 1. Y equals negative 3. So now I have x equals negative 2 and y equals negative 3. That is my solution for this system of equations. If I were to graph it, which we're going to in a little bit, I'm going to get an intersection at negative 2, negative 3. Remember that it asks me to write it as an ordered pair. Now, something to keep in mind is if you solve for y first and then x second, make sure you write it ordered pair x, y. Don't get caught up because I did this one first. It comes first. Fortunately for us, we did solve for x first, so it came first here. All right, so let's go ahead and graph it. The first one I'm going to graph in, let's see, I'm going to graph it in green. And it's already in slope-intercept form, so I can just go ahead and graph it right away. I have an a y-intercept at 0, 1, and a slope of 2, which means rise 2, run 1. Go ahead and draw in your line. Now remember, when you're doing these graphs, it's really important to try to be as accurate as possible because you're relying on them being accurate for your solution to be accurate. The next line I'm going to draw in red. But before I get too far, I have 3x plus y equals negative 9, which is not slope-intercept form, so I need to get in slope-intercept form. Subtract the 3x. I have positive y equals negative 3x minus 9. I have an intercept at negative 9. And I have a slope of negative 3, which is down 3 over 1. But I'm going to stop you for a second. We don't have enough room on this graph to go down 3. So what we're going to do is we're going to rewrite our slope, which we know is negative 3 over 1. I'm going to flip that negative sign to the bottom, and I'm going to make it positive 3 over negative 1. Same thing, it's still alright, which means I'm going to rise 3 and go to the left 1. It's going to make things easier when I go to graph it because I ran out of room on the bottom. Go ahead and draw your line in. So, I can see I have a solution here. Let's go ahead and see if it falls at negative 2, negative 3. If I go over 2 and down 3, yep. So, this one worked. So, this was my solution. Now, on your homework, I'm fairly certain that you do not have to graph to double check your work. So, it would just be as simple as solving it this way and then you would be done. It won't take you this long to do a single example. Go ahead and turn to the next page. I want you to go ahead and try doing B, C, and D on your own. B, you do not need a graph. I don't want you to graph on any of them. We'll worry about the graph when I go through it with you. So go do a B, D, C, and D on your own, but do not worry about the graphs for either of them, or any of them. Alright, I'm going to keep going, so you need to pause the video and come back to it when you're ready. Alright, first things first. Y has already been solved for. So I'm going to plug it into the second equation. I get 5x plus 3 times 4x minus 6 equals negative 1. I have to distribute that 3 to each of my terms. I get 5x plus 12x minus 18 equals negative 1. I'm going to combine like terms and I get 17x minus 18 equals negative 1. Add the 18. I get 17x equals positive 17. Divide by 17. X equals 1. Alright, now I'm going to plug that into either one of these equations. Again, I'm going to choose the first one because y is already by itself and that's what I'm looking for. And I'm going to take y equals 4 times 1 minus 6. I get y equals 4 minus 6. Y equals negative 2. So I have my x and my y, write them as an ordered pair, and I get my solution at 1, negative 2. if I were to graph that, that's where they would intersect. Go ahead and turn to the next page. All right, so first thing we notice about this one, we don't have any variable already solved for. Fortunately, that first one's going to be pretty easy because x does not have a coefficient. So I'm going to take that first one, and I'm going to subtract 2y. I'm trying to get x alone. And I have x equals negative 2y plus 6. Okay? So I've already done that. Now I'm going to take it and plug it into the second equation. I'm going to say 3 times negative 2y plus 6 minus 4y equals 28. Now, parentheses when you're putting these numbers in or subbing them in is really, really important because we have to get to the distributive property next, which is going to change your answer if you don't have the parentheses. So go ahead and distribute that 3 to both of those terms. Negative 6y plus 18 minus 4y equals 28. Go ahead and combine like terms. I have negative 6y minus 4y gives me negative 10y plus 18 equals 28. Subtract the 18. I get negative 10y equals positive 10. Divide by negative 10. Y equals negative 1. Now I have that, and I'm going to plug it in. What I'm going to do is I know that these two equations, I can choose to plug this in. But that means that since this is the same as this, I can actually plug it into here to solve for x. So I'm going to choose this equation because it's the same as that first one, and it's going to make my life a little bit easier. So I'm going to say x equals negative 2 times negative 1 plus 6. I get x equals 2 plus 6. X equals 8. I have an x and a y value. Write them as an ordered pair. I get 8, negative 1. Okay? We're not going to graph this one. I think you guys get the idea. If not, it would be better to go over it in class tomorrow as an example. Next page, I have 4x plus 5y equals 11 and y minus 3x equals negative 13. Neither of them has a variable already solved for, but this one has y without a coefficient, so that's what I'm going to go with. I'm going to say y minus 3x equals negative 13. Add the 3x to both sides. I get y equals 3x minus 13, and now y is by itself. I'm going to take that, plug it into the first equation because this is the second equation, so I plug it into the first one. I get 4x plus 5 times 3x minus 13 equals 11. Distribute that 5, and I get 4x plus 15x minus 62, right? No. Let me double check that on the calculator. 65, yikes, equals 11. Combine like terms, I get 19x minus 65 equals 11. Add the 65, and I get 19x equals 76. Divide by 19. Fortunately, that goes in there for us, so x equals 4. I did that on my calculator. Feel free to use a calculator on these. Now I just have to go ahead and plug them in. I'm going to choose this one again because it's already solved for y, so it's going to make my life easier. And I get y equals 3 times 4 minus 13. Y equals 12 minus 13. Y equals negative 1. So I have an x and a y value, which gives me my ordered pair of 4, negative 1. Go ahead and turn the page. So sometimes we're going to run into things like if I only have, I'm sorry, that's for the next page. If I have something that comes out to be false, I know that that can never happen, and it's going to make more sense when we do it. We're going to get no solution. So if you get an equation like 0 equals 4, 0 never equals 4, and you're going to get no solution. So let's go ahead and try it. I have y equals 2x minus 3, so y's already been solved for, so we're going to plug it in up here. I get 2x minus 3 equals 8. Now, something to keep in mind is I have this minus and then parentheses. Put a 1 in front so it becomes negative 1 times these things. So when I go to distribute, I get 2x minus 2x plus 3 equals 8. So 2x minus 2x gives me 0x, or just 0, and I get 3 equals 8. Is that true? No, that's never true. So we get no solution. Which would mean, if we look at the graph, we would get parallel lines. Turn to the next page. Sometimes you're going to have the exact opposite, where you get something that is always true, and it's called an identity or an infinite number of solutions. And that's if you get something like 1 equals 1 or 8 equals 8. That's always, always true, so you get infinite number of solutions. Let's go ahead and try this example together. I have y equals 2x minus 4. Y has already been solved for, so let's go ahead and plug it into the second equation. I get negative 6x plus 3 times 2x minus 4. Don't forget your parentheses, equals negative 12. Go ahead and distribute that positive 3. I get negative 6x plus 6x minus 12 equals negative 12. Negative 6x plus 6x is just 0x, so 0. Minus 12 is just negative 12. Does negative 12 equal negative 12? Yes. Always true. So we have an infinite number of solutions, which, remember from section 6.1, is two lines that lay on top of each other. They're the exact same line. Alright, that's the end of the notes. Go ahead and take a look at your homework. Be sure to ask any questions that you have. We will go over those examples tomorrow in class.